So it says, what is the molality of the following aqueous sucrose solution? So important thing right there, it's asking for the molality of an aqueous sucrose solution, which basically just means a water solution, right? Aqueous means water. A water solution that has basically sucrose, which is a type of sugar, dissolved in it, okay? So that's what we're trying to figure out. Now, it gives us a couple of different solutions that we have to solve the molality for, but we're just gonna do letter A, which is a 0.100 molar solution with a density of 1.0119 grams per milliliter. Okay. So just like any stoichiometric problem, what do we have to do? We have to figure out what?
Where we start and where we end.
Exactly, right? What we're starting with and what we're going to finish with. Now you'll notice this one's a little bit different though, okay? Let's see, what are we finishing with? We know what we want to finish with. What do we want to finish with?
Grams?
Not grams specifically. Grams could play into it, but what is the question asking for? What's the finishing point? What is the molality, right? So M, molality, we use this cursive M of sucrose solution. So I'm just going to put sucrose solution. So we want to know the molality of sucrose solution. What are we starting with? Do they give us an actual thing to start with though? Do they give us like grams or maybe moles or something like that? What do they give us? In this case,
wait, I'm grabbing my book.
Okay. What do they give us to start with? What do you guys think?
Density.
So they do give us density, right? They give us density, but sorry, give me 1 second. They give us density, but density most of the time is going to be just like something that we use for like a step, okay? In this case, I would say your starting point would be the molarity that they give you. So what's the molarity that they give us for letter A? It's going to be 0.100 molar of the sucrose solution, okay? All right, now, are we going to use density? Most likely, okay? So I would say even though we're not making that what we're starting with, still write it down here, okay? I'm not gonna write it down so it doesn't take up too much space, but I am gonna write it up here so that we know that we can use it. So that we know that we can use it, okay? So remember density, we do with that weird P. The density in this case is 1.0119 grams per milliliter. Can you guys hear that? No, I'm getting calls, I'm sorry. Okay.
Yes.
You can hear the calls?
Oh, no. I thought you were asking
okay.
like we could hear you.
Okay. Sorry. You can't hear anything?
Like I don't hear the call.
Oh, okay, good. Okay, thanks. Perfect. All right, so we want to find this, and we're starting with this. This is going to be something that we're going to use, okay? So right off the bat, we are now dealing with molality, which is a little bit different, okay? Molarity was moles of solute over liter of solution. Molality is going to be moles of solute over kilograms of solvent, okay? And that's different. Remember that density is going to be mass over volume. So we're going to pretty much use the same things that we were using last time. All right. We're still not doing anything really different. Now we're just solving for the molality. Now let's think about it. Okay. Molality, it's asking us for the molality, which means we need to know two things. We need to know the moles of the solute and we need to know the kilograms of the solvent. Okay. Do we have either of these two things right now as it is? What do you guys think? Do we have either of those two things? Do we have moles of solute or kilogram of solvent with the information that we've been given? Let's think about what we've been given. We've been given density, right? Which is grams milliliter of the solution, okay? So we don't have kilogram of solvent here, right? Because we have grams of solution and we have milliliters of solution, right? Okay. And then we have 0.100 molar, which molar is molarity, which is moles of solute over liter of solution. So do we have anything that could be applied to molality?
No.
We don't directly, but indirectly we do, okay? Because in molarity, we have moles of solute over liter of solution, right? So this is molarity. That means that you have 0.100 moles of the solute per 1 liter of solution. So you do have moles of the solute. For a liter of solution, you're gonna have 0.100 moles of the solute, okay? So that's why we use the molarity as our starting point, because it does give us something that we need at the very end, okay? Now, remember though that we need to find the mass of the solvent, okay? We have moles of solute. What is the moles of the solute? What is the moles of the solute? It's gonna be 0.100 moles, okay? But only if there is 1 liter of the solution, okay? So let's keep that in mind, all right? We know this part so far. Now we need to find the kilograms of the solvent. That's gonna take a little bit of work. One, because we only know information about the solution. We don't know information about how much the solute weighs, and we don't know how much the solvent weighs. We know how much the solution weighs though, okay? So if we can figure out how much the solute weighs, then we can subtract that from how much the solution weighs, and then we can find how much the solvent weighs, okay? And I'm saying weighs, but I'm talking about the mass, okay? We know we can find the mass of the solute because we know moles of solute. How do we find the mass of something if we know the moles? What do we have to use? It's in that sentence.
The periodic table or no?
Periodic table, exactly. The molar mass, right? Or you could just use Siri, okay? So you could just ask them, okay? But let's map out the first step, okay? The first step that we're gonna have to use, that we're gonna have to do, is find out the mass of the solute. Now that may not make sense right away, right? Why would we need to find the mass of the solute if we already have the moles of the solute? The reason is because we know the mass of the solution. There's no way that we can figure out the mass of the solvent if we don't know the mass of the solute, okay? Back into this right here. I have a cup of solution, right? In my cup of solution, let's say I add some mass of solute, okay? And now I know, let's say that this is a scale, I measure this, right? And I know the mass of this whole thing, which in this case would be the density, okay? I know the mass of the solution. How am I gonna find the mass of the solvent? I would need to figure out the mass of the solute. Because if I know the mass of the solution and I know the mass of the solute, all I need to do is take the mass of the solution, subtract the mass of the solute, and then I know the mass of the solvent, or just this part, okay? All right, so I hope that makes a little bit of sense. So that's what we're gonna have to do. We need, the first step in this case, we need to know the mass of the solvent. So we're gonna find the mass of the solute and then be able to subtract it from the mass of the solution, okay? So first step, let's figure out the mass, and I'll write it down. Find mass of solute, okay? And that's easy. How do we find the mass of the solute? We're going to use the periodic table. So what are we starting with in this case? How many moles of the solute?
The sucrose one,
Yeah. How many moles of sucrose are there? And now remember, we're referring this to all 1 liter. Okay, so pretending that the whole solution is 1 liter, because that's the only way that this will work here, right? The molarity is if we were in 1 liter. Okay. So how many moles of solute do I have for 1 liter?
0.1.
Yeah, exactly. 0.1. 0.100 moles of sucrose per 1 liter of sucrose, right? And I wrote out liters. I just meant to write the L, okay? So I have that. Now, how do we find out how much, what the mass is? We have to use the, say it, molar
Yeah.
molar mass, right? Okay. All right, so let's just ask Siri. Hey Siri, what is the molar mass of sucrose?
The molar mass of sucrose is about 342.3 grams per mole.
Okay, so 342.3 grams, okay, grams of sucrose per 1 mole of sucrose. Okay, so let's go ahead and let's do this calculation. Let's take our calculator. All right, we have 0.100 times 342.3. Okay, and then what do we get? As our answer there, we get 34.23 grams of sucrose. Okay, and remember though that it is for 1 liter of the, and it's not liter of sucrose. Wow, I messed up here. It's not liter of sucrose. It's a liter of solution. Okay. All right, so this cancels out, this cancels out. Okay, we have grams of sucrose, and we're just gonna write it here per 1 liter of solution. Okay, that means that if you have 1 liter of sugar water, okay, that means that you have 34.23 grams of sucrose if it is this molarity. Okay, let's go ahead and let's circle that just so that we know to refer back to it. All right, so next step, we now know the grams of sucrose, okay, in the solution that we were given. All right, how can we figure out the kilograms of just the water? We need to now use the grams of the solution so that we are able to subtract it. But let's look at something in the density here. The density, this is basically the grams per, the grams of the solution, but per milliliter, okay? So remember that density doesn't matter what unit you're gonna use, okay? You can pick the unit that you're gonna use. Density just means mass over volume, okay? In this case, they gave us a mass in grams, which is what we want, right? Well, eventually we're gonna have to change it, but we have the mass in grams, right? But over the milliliters, okay? So what are we gonna need to do? To be able to use this density, we need to convert this into grams per liter, okay? Why per liter? Because remember that we've been using the solution, the molarity in per liters, okay? So the next step would be in finding, and let's say 2A, okay, so that we can find the, I think someone drew on the thing right there. So see if you can erase it. To find the mass of the solvent, so just of the water, we need to find the mass of the solution first. So let's find the mass of the solution first, which is basically by using the density. Now, we want it in grams per liter. So we're gonna do another thing right here. Now, we have that 1.0119 grams of solution per 1 milliliter of solution, okay? and we want it to be in liters. So what can we use? Can someone tell me what conversion factor we can use to turn this milliliters into liters? What do you guys think?
1/1000.
Exactly. Actually not 1/1000, but
1000/1.
1000/1. Yes.
Okay.
Okay. Sorry, give me a second. Can you guys still see? Can you guys still
Yes.
see what I'm doing? Yeah, okay. Exactly. So here what we're gonna do, 1000 milliliters of solution of the sucrose solution over 1 liter of the solution. And that's just a conversion factor so that now we can get this over liters, okay? Now it's gonna be really important that you have all of your units matching up. Remember that molarity is moles of solid over liters of solution, okay? So if you're gonna be using density, your density is gonna have to be over liters to be able to match it with this, okay? And that's exactly what we're doing here. All right, so we're gonna go ahead and we are going to just work this out. Let's make sure that things cancel out. Milliliters of solution cancels out. Now 1.0119 times 123, and that's going to be 1011.9 grams of solution per 1 liter of solution. Now let's look at what we were able to do here now, because we just we made it really easy for ourselves. Basically, we have this solution, right? We have this cup, okay? Now inside that cup, we know that the whole cup by itself, the whole cup with everything inside, with all of the sucrose inside, has a mass of 1011.9 grams, okay? The grams of the solution in 1 liter of the solution, okay? And now the sucrose, so just the sugar, has a mass of 34.23 grams of sucrose per 1 liter of solution. So now you can see how easy it is, right? To take out the sucrose, take out the 34.23 grams, right? From the solution, and now you don't have solution in here anymore. What do you have in here? If you take out the sucrose, the solution becomes just what? Just the
solution?
not,
Like the solute?
not the solute, the other one. We took out the solute, the solvent. Exactly, the solvent.
Oh,
Okay?
solvent.
All right. So just like that, that's exactly what we did. So let's go ahead and do that, okay? And then this is the next step here, which I'll title it 2B, is to just do a simple subtraction. All right. So we have 1011.9 grams of solution minus 34.23 grams of solute. And I'm going to write solute here, okay? Even though we know that it's going to be sucrose. Okay, and then what do we get when we do that? 11.9 minus 34.23, and then we get 977.67 grams of what? Grams of solvent. Okay, and what is the solvent in this? We said it at the beginning of the video. What is the solvent here? What is the solvent? What type of solution is it? Quickly, guys, help me.
Aqueous.
It's aqueous. Any aqueous solution, that means it's dissolved in?
Water.
Water, exactly. Okay, water, H2O, right? Okay, and then remember that this is all per liter, per 1 liter, okay? So I'm not even gonna write that. We know that in 1 liter of the solution, the sucrose has a mass of 34.23 grams, and the water has a mass of 977.67 grams, okay? Are we done? We found the mass of the solvent, but let's look at molality. Molality is moles of solute, which we know from the beginning, right? Over kilograms of solvent. So is this gonna fly? Is grams of solvent gonna be okay?
No.
No,
No, it has to be in
we need to
moles.
convert it. Exactly, we need to convert it. So how do we convert grams of solvent into kilograms of solvent? What do we have to do?
You multiply by its like molecular mass.
No, that would be if we were trying to find the moles, okay? So you're onto something, but that's not what we have to do right now, okay? This is actually a simple calculation, right? How do we convert from grams to kilograms?
Divide by 100.
Not 100, 1,000, right? Remember that there are 1,000 grams in 1 kilogram, okay? So we can make this into a bridge notation if we want, but just know, since you know that basically there's 1,000 grams in 1 kilogram, you're just gonna have to divide by 1,000, okay? And if you divide by 1,000, that means that you're gonna be moving the decimal point to the left 3 times, okay? 1, 2, 3. So now this becomes 0.97767 kilograms of solvent. All right. Okay, so that's what we have here. 0.97767 kilograms of the solvent. All right. Are we done now?
No significant digits.
Okay, so we can use the significant digits, but we're not completely done with everything. So we're not going to do significant digits yet, because what is the question asking for?
Oh, the molar.
Molality of sucrose solution, right? So we have everything we need, right? We did this whole thing just to get this right here, okay? But we started by knowing molality is going to be moles of solute over kilogram of solvent, right? So we're going to use the moles of the solute, which we know is 0.100 moles, right, per 1 liter. We're still always referring to this as a 1 liter solution, right? The solvent in a 1 liter solution is going to have a mass of 0.97767 kilograms. So let's just find the molality now by just using this equation right here. Okay, so step 3 would be to find the molality by using M equals moles of solute over kilogram of solvent. All right, what are my moles of solute in this solution? What are my moles of solute in this solution? Moles of sucrose. What are my moles of sucrose?
3, 4, 23.
So that's my grams of sucrose. To find the grams of sucrose, I needed to know my moles of sucrose. So what do we start with to find this?
I don't know.
Right here, 0.100 moles of sucrose. Guys, how did we figure this out? How do we know that there are 0.100
Periodic table.
moles? Not by using the periodic table. It was actually given to us, right?
Oh,
in the
given,
very
yeah, you're right.
beginning, right? Here, moles of solute, 0.100 moles, okay? And how do we know that? You guys need to understand that this big M right here almost always is just telling you the moles, okay? The big M, don't let it confuse you as some like abstract concept. It's moles of solute per 1 liter of solution, okay? Most of the time, you're just gonna be working with 1 liter anyways, right? So this is just telling you the moles, okay? At least for high school chem. Later on, when you don't have just 1 liter, 1 exact liter, right? Or you're doing calculation a little bit differently, then you have to do some conversions. But in this case, that big M, just kind of think about it. Don't like say, okay, that just means moles. No, it means the moles of the solute per 1 liter of solution. Okay, so we know that we have 0.100 moles, okay? So
Okay.
we know 0.100 moles of sucrose. We're just going to say solute over kilogram of solvent. What is the kilogram of my solvent? 0.97777 kilograms.
0.67.
Yes, exactly. This one right here.
Oh yeah,
Yeah, because remember we converted it from grams to kilograms.
right.
Mm-hmm. Okay. And now let's just solve. Okay, using our calculator here. All right. So if I have 0.100 moles of solute over 0.97767 kilograms of solvent, then what I'm going to have to do here is just put it into my calculator. 0.100 divided by 0.97767. Okay. And here's what I get. So that my final answer here, and I'll go ahead and I'll write it in a different color. My final answer is 0.10228 molality, okay, of this sucrose solution. But are we done, Matthew?
No, we
No,
need
what do we need
significant
to do?
digits.
Significant digits. How many significant digits did we start with?
3.
3. Are you sure? We have a 0 here.
No, but it's 4.
Oh,
not on the right of the decimal.
Exactly.
Oh no, it's 3.
It's
So
3. It's 3,
it-
right? Remember, don't get confused, all right? I'm trying to confuse you guys. No, leading zeros are never significant, okay? In this case, we only have 3 significant digits. So let's just do 3 significant digits here. This tells me to stay where I'm at, right? So what's my final answer? What's my final answer?
0.102.
102 molal. Okay, that's how we say it, molal.
Oh shoot.
Final answer. Okay? And that's it. All of that just for that little number. Okay?